So recently I made my first contribution to open source, and I'm making this video to document kind of what I did and my thought process behind things, and um, yeah, just so I guess kind of like everything on this channel, just so I have like some sort of record of it. So the project I made a contribution to is called Zathura, and Zathura is a document viewer. I personally use it for viewing PDFs. It has Vim style keybinds, it has a very customizable config, lots of plugin support, and it's open source. I recently bought a Mac Mini off Facebook Marketplace, and when I went to go put Zathura on it, I noticed that there was an issue with the fork flag, which is something I use all the time in Linux, and I wanted to figure out why. So I actually saw an issue was already posted, and it was tagged that he wanted help fixing it, so I decided to give it a stab. So as I was saying earlier, the issue that was reported was involving invoking the fork flag would cause an error spam on macOS. The original poster of the issue mentioned that it was using a lot of system resources, and it's just not the functionality you'd expect from calling it with a fork flag. For those who don't know, calling with a fork flag, you'd expect your terminal to be free to be used by whatever else, not filled with errors. So yeah. So looking at the error closely, we can note a couple things. First of all, this NSXPC listener, which is a listener that waits for new incoming connections, which it'll then configure and choose to accept or reject them. A daemon typically has at least one NSXPC listener object that listens for connections to a specified service name. And as you can see, it's having an issue with com.apple.viewbridge, which is how apps connect to the Windows server. And then one final thing I want to point out is if you look right here, you have your PID and your thread ID. So looking back at our screenshot of the error message in the terminal, we can note that the PID is having issues is 7247, in this case at least. And if you take a closer look using PS and then grepping for Zathura, you can see that that same PID 7247 is having issues. So now we know that the child process is what's giving us issues. Because when you fork, there's going to be two processes, so you need to figure out which one is giving you the issue. So before I go any further, I kind of want to define some stuff. First of all, I want to talk about how fork works on Linux. Now that I think about this, you might not be able to see kind of this picture fully, but it shouldn't really matter too much. So basically, fork is a syscall that creates an exact copy of the calling process. The copy process has all the same memory and descriptors, PID lineage, whatever, as its parent. All open file descriptors are duplicated, and the parent and child share the same file table entries. And as a result, there are two processes, each running separately from where fork was called in the code. I live very close to the airport, so there's always airplanes flying above. So I'm trying to not talk while they're flying right above me. So for an example of a fork, if I take this basic C program right here, as you can see, there's two branches. A branch that mentions it's a child and what its PID is, and a branch that says it's its parent. And how this works is in the child process, fork is going to return 0. So it's going to hit this branch, and the parent, obviously the PID is not going to be 0, and it's going to hit this branch. So if I run this, what's that called, fork example? As you can see, it does what you would expect it to do. It has one parent process, which hits this branch, and one child process, which hits this branch. So fork behaves a little differently on Mac OS than it does on like Linux, for example. And that's because Mac has something called mock ports, which are IPC endpoints which are tied to the PID of the process that owns them. An IPC endpoint is used by XPC launched, and maybe not most important, but in this context, we're doing stuff with the Windows server. So after forking, the child will inherit the mock ports of its parent, but this port table is still linked to the mock ports of the parent's PID, which causes issues because the child's a new process, so therefore its PID is unique, but the mock ports are still tied, but the child's mock ports are still tied to the parent's PID. So when the child tries to use its mock ports, the kernel doesn't know what's happening and it rejects them, and it causes that XPC error flood that we saw earlier. Okay, so how to make fork behave on macOS. So this is a relatively common thing, and it's pretty well documented that to get around this, you want to do fork followed by an exec. And what an exec is it replaces the current process image with a new process image. So it keeps your process ID the same, but it gives the new process new mock ports, or maybe that's the wrong way to say it, but it rebuilds the process image and therefore it has new mock ports. So as I said in the last slide, the parent and child share the same mock ports, or may not share the same mock ports. Damn, wow, I'm just messing all this up. But when the child tries to use its mock ports, the kernel will throw an error since the PIDs don't match because the child's mock ports are still linked to the parent's PID. So using fork plus exec basically will transform your child process to be its own process, which separates it from the parent's resource table and including mock ports. So the new process keeps its old PID from the child, and as a result, there are two processes, one running Zathura and one in the background, which will end up freeing the terminal. And if I take a if we look at a code example of this, and we cat exec fork example. Or let's clear this and then run that command again. Okay, so this is another basic C program, similar to the last one where you have two branches, one which checks if the PID is 0, and one that doesn't. So basically what we can expect out of this is this will not print because, so kind of how fork works, we were saying earlier, is it's going to run two processes on the same code from where you call fork. But when you call exec, it basically starts from scratch. So I think that's the best way I could describe it. So if I run fork exec example, as you can see, it has your parent ID as you'd expect, and you have your child before exec right here. But something that's important is that when you call exec here, it never hits this print statement because it's basically starting everything over from scratch, which is kind of interesting. So how did I implement that in my solution? So basically it was simple. I basically wanted to save the argv before it got removed because Zathura will mutate and remove it. And what the argv is, it's Zathura -- fork and then your PDF. So then I wanted to build the new argv without -- fork since you don't want to get into an infinite loop of the process forking itself over and over again. And if you open multiple files, it'll append them in order. So there's just one command per file. For example, if you had Zathura -- fork a.pdf and b.pdf, it'll become two separate commands. So Zathura a.pdf and then Zathura b.pdf, and then you call exec with that rebuilt argv, as you can see here. There's a different way you can simplify this by using POSIX or POSEC. POSIX? Damn, I've actually never had to say that word out loud. I think it's POSIX though. So POSIX stands for Portable Operating System Interface. And it was created by IEEE to make things more portable across the various different Unix operating systems by providing a standard interface that an OS has to have to remain in compliance of POSIX. Wow, now I'm very insecure how I'm saying that. The interfaces that POSIX provides only state what functions need to exist and what the function should do. So as a result, behavior can vary between operating systems since the implementation behavior is up to the kernel. Looking more specifically at Mac, Mac OS's core OS is Darwin, and Darwin is a combination of the mock kernel and FreeBSD. So Mac's use of Darwin is kind of where the mock ports come from that we talked about earlier. And because POSIX only provides an interface, how the IPC resources are handled across forks are up to maintainers of the kernel. So the POSIX interface provides a function called spawn, which does fork followed by an exec in one operation. You technically couldn't consider this a replacement for doing a fork plus exec because you can do things in between your fork and exec, if you want to modify your file descriptors or something, which you lose that when you do POSIX spawn. But in this case, it's close enough since Zathura wasn't doing anything like that. Typically, you'll use POSIX spawn on systems without hardware support for memory management. And obviously, in this case, we're not doing that. But ultimately, POSIX spawn creates a new process image without the child inheriting the mock ports, which is what we want. So I pushed that commit up, and I got a comment from the maintainer asking me what glib is doing. To quickly define glib, glib is a general-purpose utility library developed by the GNOME project. GNOME is also one of those words I've never had to pronounce, but I'm pretty sure my professor in college called it GNOME, but it could be genome. Yeah, I guess a lot of words I haven't had to pronounce today. It's a dependency of GTK, which is how the GUI is done for Zathura. So glib provides functions over OS operations, such as PostXSpawn, that act as abstractions. So the same function works the same on Linux or Mac OS without needing different branches for each platform. If you look at the image on the right, as you can see on line 206, there's a branch for Apple. I guess I could have done better with the screenshot and showed the Linux branch too, but it basically, using the glib library, you can remove all this branching because glib's going to handle that internally. So I looked through the docs and I found gspawn async, which is glib's wrapper for spawning processes. It actually uses PostXSpawn under the hood. And since glib is already in Zathura, opting for gspawn async was a no-brainer, as it required no extra dependencies and eliminated the need for platform-specific branching. As I said earlier, glib handled all that internally, and it kind of made things, and it made everything common between the different platforms. So it was very nice solution. And something I want to comment too is we went async over sync because we wanted to daemonize the process to end up freeing the terminal. Kind of like what I was talking about earlier, how PostXSpawn isn't the same as doing a fork plus exec, but in my case it was. I was originally using gspawn async with pipes and FDs, but since I wasn't taking advantage of control over FDs or pipes, I later opted for the simpler gspawn async. So yeah, that's kind of the same as I was saying earlier about how in my case, because I wasn't, I guess because I wasn't modifying, file descriptors or anything that you could do between a fork and exec call, it's pretty much the same as doing a PostXSpawn. So as you can see, looking at the right again, my Apple branch went away and all this stuff became common between all the different platforms. So I pushed that commit up and everything was good, but I did get a comment revolving the set session ID issues, which is something I overlooked. I've been reading the advanced programming in the Unix environment, and I haven't got to that chapter yet. So I had no idea this was even like a thing, but I overlooked it. And basically, without it, the child process inherits the parent session, which stays tied to the same terminal. So I guess from the book, whenever we press the terminal's quit key, the quit signal is sent to all processes in the foreground process group. So basically what that kind of means is that you can't close your terminal that you opened Zathura from without it killing Zathura, which kind of defeats some of the purpose of freeing the terminal in the first place. In my workflow, I would never do this, so I had no idea that this was even broken. But basically creating a new session ID for your child process makes it so it doesn't belong to any terminal. So taking a look at like this example here, it's going to kind of follow the same as the other examples where you're gonna fork, and then if you're the child, you're going to get your session ID, and then you're going to call set session ID, and then you're going to see that the child's session ID updated. And so yeah, okay, so if we run set this, so the parent session ID doesn't matter, but you have the child session ID, which is 1404, and then after you call set SID, the child has a new session ID. So that's how that works basically. So as I said before, now allows Zathura to kind of run independently of your terminal. Yeah, I mean, that's pretty much it. It was a relatively straightforward change. As I was saying earlier, I've been reading through the advanced programming in the Unix environment book. So to be able to kind of take some stuff that I learned from that and apply it to this PR was kind of really rewarding. Plus, I recently bought a Mac, and I've been kind of setting it up and figuring out how to use it. And I was having this issue with Zathura, and then I saw the issue had been posted recently, so it was kind of perfect. I was able to fix something that I actually use. In the future, I want to make more contributions to the project. I'm gonna keep an eye on the issues page, and if anything catches my eye, I'm gonna try to work on it. So yeah, no, that's it. So I appreciate anyone who watched this. Sorry if it was a little confusing. I don't really dabble in C or systems programming, but I've been trying to learn. So people actually watch these videos for however reason. I don't even know how people find them. So, but if someone finds them and I said something wrong, please correct me in the comments. I'm trying to learn. So, okay, so I'm editing this video real quick, and I want to kind of just put one last closing note. I want to say that this is something that anyone could do. I think it might be obvious to some people that anyone could do this, but when I was first starting to learn to program, 4-5 years ago at this point, I always thought people who contributed and maintained open source code were super cracked, and that I would never get to that point. And I want to just kind of throw this note in here because I'm in no way cracked or anything. Like, I am a very, like, probably like, B minus average programmer. And obviously, this wasn't a perfect submission. And I want to like highlight that, where it's like, even though I was a little rough around the edges, like, it took me a little while to get the implementation that was satisfying. And at the end, I still was like missing the session ID stuff, which had to cover for me. But it's like, I still was able to make a contribution and have my name in the Git blame. So that's just something I just want to tack on in this video, that you can do it too. And yeah, don't be afraid to read and learn and contribute. So yeah, anyway, have a good rest of your day, everyone. Take care.